Let's do number 1, check your understanding together. And I'm not going to do the other ones from this one. But 1 is basically taking all those rules and putting them into effect. Do you guys think you could do A? Yeah? Try it. The one thing I would want to make sure you notice is that all the logs have the same base. So that means you can start using those rules of condensing. Do you have A done? What is it?
Log base 3 in parentheses 4W over 7.
That's it. Log base 3 of 4W over 7. The logs that were being added, we multiplied in the argument. The one that was being subtracted became division in the argument. Okay with that? What about B? What's the base of those logs? I don't see a base. I'm confused. Yeah, what's the base? Nope. E. Natural log has an understood base of E. If it was an log without a number, then it's a base 10. But ln, the natural log has the natural number, which is E, as its base.
You call it natural.
It is the natural number. Okay, what's different here about B?
It has a 2.
2 out in front. So if I'm going to rewrite the logs, that has to become an exponent. So this is actually a 2-step problem. This is the natural log of 5 squared minus the natural log of 4. So before I can do the subtraction of logs, I must make sure there are no coefficients of those logs. So I need to move it up to be an exponent first. And then this is the natural log of 5 squared over 4. Or you could write that as 25 over 4. Either one of those, that's fine. Questions? Here is here's the second half of that lesson. So after if we were in class, you'd taken the quiz, I'd have taken the quiz up, and then I'm supposed to teach you this. And then let you do the check your understanding. So all I'm going to do today is I'm going to teach you this, and then give you the check your understanding as homework. Now the weird thing is, we're going to be using these rules in the lesson I'm going to teach later on. So I think you're going to get more practice with it and feel better with the check your understanding. So the way that I have it memorized is I really have it the other way. So I talk about what's in parentheses as being the argument. Do I need to, okay, we're going to copy. That's fine.
This seems like stuff we need to know.
It is. I was going to explain to you how to do it instead of just blindly copying, but I forget y'all just would rather copy and...
We want both.
Well, I don't need to do both at the same time. All right? I was going to explain one and then say, no, you can write that one down. Then I was going to explain the next one. It's on me.
I'm sorry.
Don't write any of this down yet. Don't worry about this side. Just look at the left side. Those 3 ways to rewrite logarithms. Have you guys done logarithm rules before? In Algebra 2?
He says yes, but
I mean,
Anthony says yes.
I think we did, but do I remember it?
Okay. So again, the part that's in parentheses here, I call it the argument. So every time you hear me reference the argument, this is what I'm talking about. It's what's over here, inside parentheses. So if I have two things being multiplied in the argument, that's what this is saying. X and Y are being multiplied in the argument. I can rewrite it as addition of two separate logs. So multiplying in the argument becomes addition as separate logs. Okay, do we follow that? Division in the argument becomes subtraction of the logs. It's always the numerator minus the denominator. So what's on top minus what's on bottom. And then lastly, exponents in the argument. If I have an exponent in an argument, it can be written out front as multiplication of the log. So if we had time, I could explain why this makes sense in terms of the math that we're doing. We don't have time. So you really don't have to know how it works. Just this is what to do. Okay? I'm not going to give you the why, just for time's sake. Okay, these learning targets. Logarithm properties reveal that different transformations have the same effect. Well, we've already looked at that with exponentials. Remember how a stretch 3 is the same as a shift left? You just had that on the test. Well, the same's true for logarithms. If it's true for an exponential, it's true for a logarithm. That I could do something different, but it actually gives the same graph. Logarithms of different bases can be related to one another. That's the most vague thing ever. We'll get there. Notice how all of these had the same base. So while I talked about going in this direction, you could also go in the other direction. You could condense it. If I have two logs with the same base being added, I can rewrite it as multiplication of the argument. Or subtract it, I can rewrite as division. Or if there's a coefficient being multiplied in front, I could rewrite it as an exponent. It goes in both directions, either condensing the log or expanding the log. That's what those big arrows are talking about. Are we good? Any questions? Okay, so remember the problem on the test I told you didn't know how to solve because you didn't know how to get it out of the exponent? Well, we're fixing to start learning how we could have solved that. So look at number 1. It tells me to solve for x. Write out each step. So if you had to solve for x here, what would you do? You simplify first, so combine like terms. So right there, those two combine to be 2x squared. And then negative 9 plus 4, that combines to be negative 5. Equals 27. Then what would you do? Move the 5 over, it becomes positive. So now I've got 2x squared equals 32. Then what would you do? That's it. You have to isolate the variable, so divide by 2. So x squared equals 16. Then what? Then take a square root. So what would you get? X equals plus or minus 4. I took the square root. I must account for the plus or minus possibilities. So plus or minus 4. So the things they wanted you to see there was we combined like terms first, and then we just did a bunch of inverse operations, right? If it was being subtracted, we added it. If it was being multiplied, we divided. If it was being squared, we square rooted it. We combined like terms, and we did inverse operations. This is the same idea for what we're going to be doing here in a second. So let's fill in the blanks here for these question marks. 3 question mark equals 81. What would the question mark be? 3 raised to what power is 81? Oh, no. Oh, gosh. When we go to the calculator, that's not a good sign.
I don't know what it is off the top of my head.
It's not 6. It is 4. You were, did you multiply?
No.
19. Oh, well, yeah, that's where we're getting. Not yet, though. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 243. Times 3 is 729. Okay, I'll stop there. Okay. I didn't want to do the next one in my head. The next one is? Did you calculate it? Yeah, okay. I could have done it, but I didn't want to. I'm wasting time. Showing off is not the point of today. Okay, B. Log base 17 of what is 0? No calculator.
Well, it's not 0.
No. What's this asking? Do it. To me, I don't like looking at it as a logarithm. So you could rewrite this as an exponential. So what's this asking? How does this rewrite as an exponential? The base raised to the answer equals the argument. You've got to know how to do that. Go from logarithmic to exponential. Base raised to the answer equals the argument. But what's 17 to the 0 power? Well, hopefully we just learned that when we went over the test. And you guys, right? Remember, almost anything to the 0 power is 1. 17 is no exception. I don't have time. 0 raised to the 0 power is the exception. Because what is 0 to the 0 power? And everything. Yeah, it is undefined. Anything to the 0 power is 1, but 0 to any power is 0. So which one wins when it's 0 to the 0? Neither one. Okay, C. Log base 36 of what equals a half? So what's this asking? 36 to the half. Yes, thank you. Remember, a half exponent is the same thing as a square root. So this is 36 to the 1/2 is the square root of 36, which is 6. We good with that? The last one. 4 raised to what power is 27? Duh. So it's nice when it's things that we know. But what if it's something we don't know? Like, what's 4 to the 2nd? 16. What's 4 to the 3rd? Uh-huh. 64? Yeah, double it when you multiply by 4. Double. So 16 double 32 double 64. You with me? Double doubles times 4. Anyways, it's somewhere between 2 and 3, the exponent. Yeah? What do you think it is? 2 point something. I don't know. You tell me. So that's what we're going to do is we're fixing to learn how we can solve that using logarithms. And we can get the exact answer. All right, let's keep going. 3, rewrite the equation in its alternate form. Which means if it's exponential, write it as logarithmic. If it's logarithmic, write it as exponential. Don't solve. So 3 raised to what power is 81? If I had to write that as a logarithm, what would that be? Log base 3 of So remember here, so I get confused too. So I have to go back to look at the logarithm. This is the base raised to the answer. So this is the thing that's raised to. Correct. So we're taking the argument of 81. Log base 3 of 81 equals, I'm not sure. And then I told you guys I only know how to do it from one direction. Like when I write this, I go back and say, what's this asking? 3 raised to what is 81? That's what I want. That's the only direction I feel confident going from. Logarithm to exponential. I always am hesitant going from exponential to logarithmic. B we've already done. So what did we write for B? 17 raised to the 0 equals what? C, log base 36 of the question mark. This is saying 36 raised to the 1/2 equals question mark. What about D? Now I've got to write it as a logarithm. So this is log base 4 of 27 equals question mark. Why does rewriting the equation in its alternate form help you figure out what the question mark is? That's it, 100%. The question mark becomes isolated. Isn't that so much easier to solve when the question mark's by itself? Yes. Yes, it is. 5. What if the question mark is slightly more buried? Think back to question 1 and try to isolate. I used to say it's in prison. All right, so they're going burial. I'm at least not that bad in there. Okay, thank you. So what do you guys think we need to do on 5? Log base 3 of the question mark minus 4 equals 5. We would like to rewrite this from logarithmic to exponential. Do you agree? You cannot rewrite it until the logarithm is isolated. Is the logarithm isolated? No. Why not? Correct. There's 2 terms over there. The subtracting 4 is keeping it from being isolated. So undo it. So how can I undo subtracting 4? I would add 4 to both sides. We good with that? Now is the logarithm isolated? So now I can solve it. Or rewrite it, sorry. So this would be what? This would be 3 raised to the 9th equals what? And that would be a calculator question. Could you guys find that answer? I'd hope so, right? Just put in your calculator. 3 to the 9th. B, 5 times 2 raised to the 7 minus question mark equals 40. Now it looks like an exponential function. Do you see the exponential? A times B raised to the X equals, this time they've given you the Y value, 40. So if I need to isolate it, let's get the question mark by itself. You had to isolate a logarithm before you could do anything. Guess what you have to do when it's exponential? You must isolate the exponential. So here is the power, right? The whole piece. 2 raised to the 7 minus question mark. Why is this not isolated? Being multiplied by 5. How can I undo multiplying by 5? Divide by 5. So divide by 5. So now I've got 2 raised to the 7 minus question mark equals 8. So some of you could figure out what the question mark is now. What does the question mark need to be? It needs to be 4. That would make it be 2 to the 3rd power. So we could go ahead and rewrite it as a logarithm, but we actually got that simplified enough we could figure it out. Another way you could do it, you could make the 8 become 2 to the 3rd. Do you guys remember me talking about that? Rewriting powers with the same base. And so now what? We could drop the 2's and just set the exponents equal. 7 minus question mark equals 3. And solve. We okay there? What about C? The natural log of the square root of a question mark minus 8 equals 0. I hate writing question marks. Ideas. Did I show you how to work with radicals in your logarithms? No. But what is a radical? It's the same thing as raising it to the 1/2. So here, if I've got the natural log of the square root of a question mark, I can rewrite that as the natural log of a question mark minus 8 to the 1/2. Because a radical is the same thing as raising it to the 1/2 power. Agree? Now what? I have a power in the argument. What can I do with that? I can rewrite it as multiplication of the log. We good there? 1/2 natural log of the question mark minus 8 equals 0. Now isolate the logarithm. The natural log is being multiplied by half. So how can I get rid of that? Divide by half. I multiply by 2 because I'm old school, but that's the same thing as dividing by half. So those cancel. What's 0 times 2? 0. And now I have a logarithm isolated. So what can I do? The logarithm's isolated. I can rewrite it as exponential. To follow? What's the base of that logarithm? E. So this is e raised to the 0 equals question mark minus 8 equals the argument. What's e to the 0? 1 equals question mark minus 8. So then I would add 8. And so the question mark is equal to 9. Questions? Okay, what about A? Can we do A? What is it? Uh-huh. Why? It says give a reason. Yeah, same base, so the exponents must match. Okay? What about B? Same base, right? So the exponents must match. You okay if I put an X? I'm sick of drawing that question mark on here. I can't do it. It's too... And so then if I had to solve this, add 1, divide by 3. Are you okay with that? I'm running out of room. So X equals 7. The question mark equals 7. What was our reason? They had the same base. What about C? Yep, 10. Why? Because, here's the next part that we're learning. When I have a single logarithm on both sides that has the same base, you can drop it. And just set the arguments equal. Just like here, if I have the same base, I can drop it and set the exponents equal. Same idea. Okay? So here, do I have a single logarithm? On the left I do. What about on the right? So I can't drop anything yet because they're not single logarithms. Follow? Can I make this a single logarithm? So do it. So make the right side become a single logarithm. So this becomes log base 7 of 20 equals log base 7 of x over 2. Now I have a single log on both sides that has the same base. So what can I do? Set the arguments equal. 20 must equal x over 2, which means x must equal 40. You follow? 7. Combine everything we know about exponents, logarithms, and solving equations to figure out what x is. Tell me what you think you should do. You can't drop the logs yet. Why? Why is that not correct?
It's not six.
On the left side, there's not a single logarithm. You with me, Anthony? Left side, there's 2 logs. So I can't do anything until it's a single log. So could I rewrite that as a single log on the left? What would it be as a single log? Yeah. Logs being subtracted can be rewritten as division of the argument. Do you follow that? Now I have a single log on both sides. So now what can I do? Drop the logs. And I'm left with the argument equals the argument. Now what would you do? I'd put it over 1. And I would cross multiply. That's who I am. I'm a creature of habit. X times x is x squared. X plus 6 times 1 is x plus 6. Now what would you do? Nope. Square root sounds nice, but what's the problem? There's another x. You with me? So now I've got to get everything to one side, because what is this?
Oh, it's gonna be
It's a quadratic. X squared minus x minus 6 equals 0. How can I solve this quadratic? I can factor. I could use the quadratic formula. I could complete the square. I think we can factor this one, hopefully. X minus 3 times x plus 2 equals 0. So what has to be true? X must have to be 3, or x must have to be... But that's not it. Because what is this? Negative 2. Think about if I plugged in negative 2 here. What's that asking? E raised to what power is negative 2? Doesn't exist. Because remember, a logarithm graphs with a vertical asymptote. And we can't take any negative x's. The domain is only 0 to infinity. So this negative, when I plug it back in, doesn't work. And so the only correct answer is 3. So when we solve these logarithms, you have to also check, is it valid for the domain? Is it valid for the domain? Because not everything will be. That's a lot. Hopefully you got kind of an idea how to simplify logs, and then how we can incorporate other stuff we've already done this year with those logs. We're going to be okay. I promise. Good news is I won't be here the next 2 days. Man, it's awful, isn't it?
No, that's the seventh.
It is what it is. On Monday, so, okay, let me do this. As you're leaving, make sure you turn in your test. Monday, you are working a lot of logarithms without me. I'm going to post the answers. Okay? You're just working log problems. Boom, 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 boom. Tuesday, I'll have a lesson for you to watch. Wednesday, I'll be back. We'll answer what we can and get the next lesson because we don't have a day to spare. You can start doing some Canvas assignments. That will also help you with your logs. Right? I posted on Power School a rough due date for every assignment from now till Christmas.
I noticed that.
So you can start looking to kind of know what should I be getting done at about what time. Cool beans? All right, I'm done.